Welcome to the deep dive. So if you're getting ready for a senior software engineer interview, and you're thinking about RESTful API design, you're definitely in the right spot.
Yeah,
This isn't just theory, right? It's about really understanding REST for practical system building, which is, super important for senior roles. We're aiming to cut through the buzzwords today.
exactly. We're going to go deeper than just the textbook definition.
Mhm.
The goal is to really unpack how it works, why it's often a solid choice, but also, some of the challenges and the finer points that really matter in those technical discussions.
It's about sharpening that understanding for the interview room.
Precise.
Okay, so let's dive in. Core concepts first, this idea of resources. If an interviewer brings this up, what's the best way to think about it?
Well, fundamentally, a resource is just a thing your service knows about.
Oh,
Think like a customer, an order, a product, anything, really.
all right.
The key thing, though, is that the representation you give to the outside world, maybe some JSON data, is totally separate from how you actually, store that customer data in your database.
Ah, okay. So if my app needs customer info, I ask for it, maybe get JSON back, even if the service stores it like completely differently. That decoupling, that sounds pretty useful.
It absolutely is. That separation is core REST, a major plus. Clients interact with these resource representations, and they can also ask to change the resource, like updating an address.
And the server decides whether to do it.
Exactly. The server has the final say on making that change.
Now, you almost always hear REST paired with HTTP. Why is that combo so common and, well, powerful?
It's a great pairing because HTTP already gives us a bunch of well-understood tools and rules that fit really well with REST ideas.
Like the HTTP verbs, get, post, put.
Exactly
view.
those. Get,
Oop.
post, put, delete.
Done.
They aren't just random commands. They have specific, agreed-upon meanings in the HTTP standard about how they interact with resources.
Okay, so GET is for fetching data, right? And it's idempotent, calling it again doesn't change things.
Spot on. Get should be safe, repeatable. You hit it multiple times, you get the same result back. No side effects on the server.
Mm-hmm.
Then you've got POST, which is typically used for creating something new. Send a POST to customers with the right data you expect a new customer resource to be created.
Oh, right.
And the beauty is applying these verbs consistently across all your different resources.
Hmm.
You avoid making up loads of custom methods like get customer or create new order.
That makes a lot of sense. So instead of, say, create book and get book details, you just have books, and you use POST to add one, get T to retrieve them. It feels cleaner.
Precisely. It simplifies things massively
Good.
for anyone using your API.
Mm.
And beyond the verbs, you get this whole rich ecosystem around HTTP.
You mean things like caching?
Yeah, caching proxies like Varnish can store responses, take and load off your servers. Load balancers can spread traffic smartly. Monitoring tools often understand HTTP out of the box.
So these tools help with handling lots of traffic, making sure requests go to the right place, even security.
Absolutely. HTTP has built-in ways to handle authentication and security. This whole ecosystem makes building scalable, secure systems easier. But you have to use HTTP correctly.
Ah, there's the catch.
Yeah, if you misuse it, you kind of lose those benefits.
You mentioned other things use HTTP too, like a SOAP. How is REST using HTTP different from, say, SCPP over HTTP?
That's a really key distinction, especially for interviews. A SOP can run over HTTP, but it mostly just treats HTTP as a dumb pipe. It often ignores the HTTP verbs, the status codes.
Okay.
It wraps everything in its own XML format and has its own complex rules. And then something like gRPC, while it uses HTTP2's cool features, isn't really RESTful in its approach either.
So just because it uses HTTP doesn't mean it is REST.
Exactly. REST is a specific style that deliberately leverages HTTP's features.
Got it. Okay, that leads nicely into something that sounds a bit theoretical sometimes. HATEOAS. Hypermedia as the engine of application state. What's the core idea here?
Right, HATEOAS. It's basically about making the client and server less tightly bound together. Think about hypermedia like links on a web page. They connect related pieces of content.
Mm-hmm.
HATEOAS applies that idea to APIs. The client interacts with the API, discovers what it can do next, and triggers state changes by following links provided in the server's responses.
So instead of the client needing to know the exact URL for, I don't know, orders 123 items, the server response for order 123 would actually contain a link labeled items pointing to that URL.
Exactly that. The client doesn't need hard-coded URLs. It gets a resource, looks at the links inside, finds the one it needs, like view items or cancel order, and follows that link.
There was an analogy, I think, about an Amazon shopping cart. How does that illustrate it?
Yeah, that's a good one. Think about using Amazon. The little cart icon might change shape, move around the page. The URL behind it might even change over time. But you as a human still recognize it as the shopping cart and know clicking it takes you there. You understand the meaning, the relationship. HATEOAS aims for that kind of dynamic discovery for software clients.
Okay, so if I get back info about an album, the response might have links like rel artist info pointing somewhere and maybe rel purchase pointing somewhere else.
Precisely. The client needs to understand the semantics, the relation. What does artist info mean? It means follow this for artist details. What does purchase mean? Follow this to buy it.
And the client doesn't care about the actual URL string itself.
No, it just finds the link with the relation it understands, like purchase, and follows it. The server could completely change that purchase URL tomorrow, maybe even point it to a totally different microservice.
And the client wouldn't break because it just followed the purchase link it was given. Wow, okay, that decoupling sounds huge.
It theoretically offers massive flexibility. Imagine reorganizing your entire API structure without breaking clients because they just navigate via the links.
That does sound amazing, but you also hinted it's not that common in practice. Why not, if it's so beneficial?
Yeah, that's the interesting part. And the reasons aren't, like, totally clear-cut. While the decoupling is great in theory, implementing HATEOAS definitely adds complexity.
How so?
Well, the server has to figure out which links are relevant right now and embed them correctly in every response. And the client needs logic to find and understand these links, rather than just hitting a known URL.
So more work on both sides.
Pretty much. And you need to design and agree on what all these link relations actually mean. That itself can be tricky. There might also be worries about getting the protocols just right.
So the practical effort might just feel like too much compared to the payoff for many teams.
That seems to be a big factor. Maybe for many internal APIs, the level of decoupling HATEOAS offers just hasn't felt strictly necessary enough to justify that extra complexity or potential performance hits.
Performance. Let's talk challenges. Historically, generating client code for REST was harder than for RPC, right? Has that changed?
Yeah, it definitely used to be a bigger issue. RPC often came with tools to auto-generate client code from an interface definition. REST didn't really have a standard equivalent initially.
So teams ended up writing client libraries by hand.
Often, yes.
Yeah.
Which, ironically, could tie the client and server together in a different way.
But then OpenAPI, which used to be Swagger, came along.
Exactly. OpenAPI gives you a standard way to describe your REST API, the endpoints, what data they expect, what they return, and tools can use those definitions to auto-generate client code in lots of languages.
So, problem solved.
Well, it's a huge improvement in tooling, for sure. But it's interesting, even with OpenAPI available, you don't see everyone auto-generating clients for all their existing APIs.
Why do you think that is? Maybe adding OpenAPI specs to old APIs is a pain. Or people just stick with the clients they already built.
Both are probably true. Retrofitting specs can be work. And some teams might just prefer the control of handcrafted clients. Or maybe they have concerns about the quality or flexibility of auto-generated code. It's also using something originally for documentation to define a stricter contract, which can get complicated.
Okay, what about performance within REST itself? Any drawbacks compared to other ways doing things?
There can be. REST often uses JSON, which is text-based. While usually smaller than SOAP's XML, it's generally bigger than lean binary protocols like, say, protocol buffers or Thrift.
And the HTTP overhead? Headers and stuff?
Yeah, each HTTP request has header overhead, connection setup time. That can add up, especially if you need super low latency.
Because standard HTTP runs on TCP, which has its own handshakes and things?
Exactly. TCP guarantees delivery order and reliability, which is great, but things like the initial handshake and congestion control can add latency compared to, say, UDP, which some RPC systems might use.
So isn't there HTTP3 now using QUIC?
There is. HTTP3 runs over QUIC, which aims to reduce latency and perform better, especially on unreliable networks. It offers reliability like TCP, but potentially faster. But, widespread adoption across the internet and internal systems, that's still ongoing. It'll take time.
And specific to HATEOAS, does that have performance implications?
It can, yeah. Because the client has to follow links. You might need more back-and-forth network calls to complete a task.
Like fetch the order to find the cancel link, then make another call to actually follow that link.
Potentially, yes.
Yeah.
More round trips can mean higher overall latency. It's often framed as a trade-off, You get that nice decoupling, but maybe at the cost of a few extra milliseconds here and there.
So maybe start with HATEOAS if it makes sense, and optimize later if needed.
That's often the advice. Plus, remember, HTTP itself has built-in performance helpers like caching, which REST leverages really well.
Right. So putting it all together, where does REST over HTTP really shine? When is it the go-to choice?
It's a really sensible default for a lot of service-to-service communication, especially when you need that synchronous request-response pattern and you want broad compatibility. Lots of tools and developers understand it.
And especially for APIs exposed externally, right? To third parties or front-end apps.
Absolutely. For public APIs or APIs consumed by your own web or mobile clients, REST is often the obvious choice. Its use of HTTP makes large-scale caching very effective, which is huge for performance and scalability when dealing with many consumers. The discoverability aspect, even partial HATEOAS, helps too.
But maybe not the best for all internal microservice chatter, especially if it needs to be super fast or asynchronous.
That's a fair point. While you can build async patterns over REST, it might not feel as natural or performant as using, say, message queues or RPC frameworks designed specifically for async.
Okay.
And as we discussed, the real-world evidence for massive long-term wins from full HATEOAS complexity in many internal systems was not always overwhelming.
So let's recap for someone prepping for that senior engineer interview. What are the absolute must-knows about REST?
Okay, key things. Understand resources and representations and that client-server separation. Know the HTTP verbs, get, t, post, put, delete, and their standard meanings. Use them semantically.
Right.
Be ready to explain HATEOAS, what it is, the decoupling goal, and the practical hurdles and why it's not everywhere. And finally, know its strengths, scalability, caching, interoperability, especially for external APIs, but also be aware of when other patterns might be a better fit.
Showing you understand the trade-offs is crucial at that level.
Definitely. It's not just about knowing what REST is, but why and when you'd choose it and what the alternatives are.
That's super helpful. And that leads us to our final thought for everyone listening, especially those prepping for interviews. Thinking about all these trade-offs, the elegance of REST, the power of HTTP, but also potential performance costs, the HATEOAS complexity. Where do you see the biggest opportunities and maybe the biggest challenges for RESTful principles in today's distributed systems? And maybe more importantly, how would you clearly explain your design choices, weighing those pros and cons in an interview? Something to definitely mull over. Thanks for diving deep with us.